Okay, so we're going to look at some different measures of variation. In the class before, we talked about measures of center, where we had the mean, the median, and the mode, and the mid-range, 4 big M's. We talked a little bit about how some of those are good and how some of those are not good. Now we're going to look at our measures of variation, which is the variability that you have in your data set. First one is the range. And to find the range of your values, you take the maximum value. No, this is the mid-range. Sorry. You just take your maximum value and subtract your minimum value. And that gives you your range of numbers that you have. Obviously, this is going to be very susceptible to outliers. Any outliers that you have in your data set will either be your maximum value or your minimum value. The next measure of variation is the standard deviation. And a standard deviation formula, which you won't actually be using, looks like this. Now it looks kind of weird, but let me just tell you what's happening and how we actually calculate the standard deviation. You guys will be using StatCrunch to actually calculate that. This X bar here in the middle is your sample mean. And you find that by adding up all your values and dividing by how many you have. So that's going to be the average number or the mean of your data. X represents any individual data element. So what we do is we take the difference between that mean minus that data element, and then we square it, and then we add all of those together. And then we divide by 1 less than the sample size. So we take the number of values that we have and subtract 1. And then we take the square root of the whole thing. Whenever you square something and taking the square root of something, in mathematics it's kind of like using the absolute value. So really what we're doing here is we're taking the absolute value, or the sum of the absolute value of the differences between the mean and the value. And the square root kind of does the absolute value thing. Now we don't actually do the absolute value thing because we're dividing by 1 less than the sample size. So this actually represents the sample mean. Now the population mean, which is this funny symbol here, is not something that you regularly calculate. Population mean usually comes from a very large data set. And that population mean is usually going to be given to you. Okay? Together, what these things do is it gives us a measure of variability that we have in our data set. If our sample mean is 0 or a population mean is equal to 0, this is the Greek letter sigma, by the way, just in lowercase form. If those values are 0, then all the values in the list are the same. They might be just all ones. There's no variability at all whatsoever, okay? If, however, you have some sort of value, that means that you have some variability. So the further away from 0 that value is, the more variability you have in your data set. Now I'll show you how to calculate your standard deviation in a second here. Your variance is not something that we will use in this class, but going forward, it's just the sample standard deviation squared. So we use this when we look at analysis of variance. If you ever guys do something called an ANOVA test, that stands for analysis of variance, is what it talks about. And we use this when we're talking about comparing the variability in data sets. We won't go there as part of Math 120. that is in the Math 150, Math or Stats for Life Sciences curriculum. So here, okay, and we also have something called the range rule of thumb. And this is kind of a gimmicky thing. The sample standard deviation can be approximated by the range divided by 4. We don't usually use this that much. They used to use this back in the day when they didn't have access to computers, and calculating these things was cumbersome, right? And so to get an estimate of your range, your sample standard deviation, you can take the range of your values and you can divide it by 4. Now this is one part of the definition of the range rule of thumb. The other one is the range of usual values. Oops. And the range of usual values are all of those values that are within 2 standard deviations of the mean. So we have our sample mean right in the middle of our values. And if we look at all of our values that are within 2 standard deviations of that mean, we say that those values are not unusual. And then we say that if you have any numbers that are beyond those 2 standard deviations of the mean, these are unusual values. Okay? So let me give you an example, very specifically what I'm talking about. Let's say that for men, the mean height, population mean, is equal to let's see, 5 times 12 plus, let's say it's 68 inches. Okay, so let's say that 5'8" is the average height for a man, which is pretty close. And let's say that the standard deviation for men is 4 inches. Okay? Now I'm 6 feet tall. So I'm 6 feet tall, which means that I'm 6 times 12 inches. So that means I'm 72 inches tall. Okay? So where am I in comparison to the average height of men? Well, we can do something called a z-score. And now I've moved into section 3.4, where I'm talking about measures of relative standard. And the way that we calculate a z-score is we take z is equal to mu minus the value, and we divide it by the standard deviation. And what we're going to do here is we're going to figure out where my height is relative to all other dudes. Okay? So I can calculate my z-score using this value. So for a Hedstrom, I'm going to do my z-score is equal to 68 minus 72 divided by my standard deviation of 4 inches. All right. I screwed this up. It's the other way around. It's mu, shit. That's recorded. That's great.
So I have to do 72 minus 68. That's going to be 4 divided by 4, and that's equal to 1.
What this means is that my height is 1 standard deviation above the mean.
Not unusual though, because my value here is within
My range of usual values between -2 and +2.
Okay? But let's look at Shaquille O'Neal.
Some of you know Shaquille O'Neal is a basketball player.
He and I have something very much in common that few other people have. Anybody want to guess what it is? It's not our height. It's not our basketball skills.
We are exactly the same age. We were both born the same day, March 6, 1972.
That's my only claim to fame.
But let's look at Shaquille O'Neal and let's look at his Z-score.
We all know he's very tall. He's 7 foot 2 inches tall. So that's 86 inches minus the 68 inches, which is the mean for men. And we're going to divide that by the standard deviation. So I'm going to do 86 minus 68, divide that by 4, and he is 4.5 standard deviations above the mean.
And this is what Z-score stands for. Literally says standard deviations above the mean.